Loops normally run until they're naturally done. A while loop keeps going as long as its condition holds. A for loop keeps going until its sequence runs out. But sometimes you want to leave a loop early, before either of those things happens. There's one keyword that does exactly that, and the instant Python reaches it, the loop is over. First, a quick recap of how loops repeat code and how they stop. Both while loops and for loops let us repeat lines of code automatically. With a while loop, the body repeats as long as some condition stays true. The moment that condition becomes false, the while loop ends. With a for loop, the body repeats once for each value in a sequence we choose. So far, those values have been numbers, but the sequence can hold non-numeric values too. The for loop ends when the sequence is exhausted, meaning we've used every value in it. So each loop has its own natural stopping point, a false condition for while, an empty sequence for for. Often we don't want to wait for that natural ending. We don't want to see through every remaining value or wait for the condition to flip false. We want out now. To exit a loop before its natural end, we use a break statement. Here is the one rule that matters most. A break statement exits exactly one loop, and it's the loop that immediately surrounds the break. Not the outermost loop, not every loop, just the nearest enclosing one. Keep that single sentence in mind, and break never surprises you. Let's see that rule with two nested while loops. An outer loop that runs while condition 1 holds, and an inner loop that runs while condition 2 holds. Inside the inner loop, we run expression A, then immediately a break. To even reach expression A, we enter the outer loop, so condition 1 was true, then enter the inner loop, so condition 2 was true. Both must hold for expression A to run. But right after expression A, Python hits the break. It immediately exits the loop that surrounds it, the condition 2 loop. The outer condition 1 loop keeps going. Now look at expression B, sitting after the break inside the inner loop. It never runs because break leaves the inner loop the instant it's reached. Python doesn't even loop back to recheck condition 2. Expression C sits outside the inner loop at the outer loop's level, so it runs whenever condition 1 is true. And because the break fires right after expression A runs exactly once, then we're out. Now a real Python example you can trace line by line. We have a for loop over a range, where the range starts at 5, stops before 11, and steps by 2. That gives the sequence 5, 7, 9. We stop at 9 because 11 is the end value, and the range goes up to but not including its end. Before the loop, my sum starts at 0. First pass, I is 5. We add I to my sum, so 0 plus 5 makes my sum 5. Next line, if my sum is equal to 5, it is, so we enter the if and hit break. The break immediately exits the for loop. Now the line that adds one more to my sum sits after the break, so it never runs. And notice, the if statement is not a loop, it's a conditional. So break does not exit the if, it exits the for loop, the nearest surrounding loop. With the for loop gone and nothing around it, the program prints my sum, which is 5. This is deliberately awkward code, but it shows precisely what break does and which block it leaves. Now let's switch from break to a practical use of a for loop, counting. The task is to count how many even numbers are in a range, including 0. Take range of 5. It produces the values 0, 1, 2, 3, 4. The even ones are 0, 2, and 4, so the answer should be 3. To test if a number is even, use the remainder operator written as a percent sign, often called mod. The expression I mod 2 gives the remainder when I is divided by 2. If that remainder is 0, the number is even. A handy habit, especially on quizzes, is to write a short comment next to the loop noting that I takes the values 0, 1, 2, 3, 4, so you'll never have to hold that in your head. Here is the full solution, just 3 lines that do the job. First, before the loop, initialize a counter. Even nums is set to 0 because at the start we've seen 0 even numbers. Then the for loop runs I over range of 5, so I take 0, 1, 2, 3, 4 automatically. Inside, if I mod 2 is equal to 0, the number is even. So we increase even nums by 1, since each hit is one more even number. After the loop, at the same indentation level as the for, we print even nums. Trace it. I is 0, 0 mod 2 is 0, count becomes 1. I is 1, remainder 1, skip. I is 2, count becomes 2. I is 3, skip. I is 4, count becomes 3. The loop ends and it prints 3. If you instead loop over a range of 10, you get the values 0 through 9, whose even members are 0, 2, 4, 6, and 8, so it prints 5. And if you ever undercount, check 3 things: that you initialize the counter, that the increment is right, and that the range is what you intended. Let's pull the pieces together. Loops have natural endings. A while loop ends when its condition turns false, and a for loop ends when its sequence is exhausted. When you need to leave early, break is the tool, and it exits only the single loop that immediately surrounds it. Never an enclosing if, skipping any code left in that loop. The way expression b and that extra increment line never ran. And a plain for loop over a range is a workhorse for counting. Initialize a counter before the loop, update it inside on each value that qualifies, and read the result after the loop. One rule for leaving loops, one pattern for counting with them. Master those two, and you can already write surprisingly capable programs. To practice what you just learned, this course has free exercises and AI-graded feedback on ludium.ai. The link is in the description.